Okay, let's unpack this. We are diving deep into a mystery today, a mystery that's rooted in just sheer complexity and how one very specialized analysis is being used to try and solve it. The target is one of the most, well, opaque and difficult to understand parts of modern public finance: Japan's special accounts, or the Tokubetsu Kaike. Our source material for this is a blog post, STA-0, which is the foundational document for a whole series on what they call structural transparency architecture. It sets out a methodology called GOA, Global Observation Architecture.
And the mission here is, I think, really fascinating because it's not about critiquing the Japanese government or, debating policy.
Right.
It's a pure structural stress test. The people who created this, they really want to know, can an AI, using this GOA framework, look at a system that's just so vast and so historically dense that no single human can really map it? And can it successfully break it down into a verifiable, measurable structure?
So it sounds like they're trying to build a kind of transparency OS, like an operating system for our own cognition,
That's a great way to put it.
where the hidden rules of system are made visible, verifiable, no matter how emotional the story around them is.
Precisely. And they chose the special accounts because they are the ultimate test subject. They've got complexity, they've got history, they've got inertia. If the AI can map this, it basically proves the framework can work on anything.
So let's start where the analysis itself began. The author wasn't even looking for this, were they? They were just trying to examine the R8 budget. That's the budget for the Reiwa 8 fiscal year.
Exactly. Just trying to gauge the speed and scale of the national system. And that's when this enormous, almost separate world of the special accounts just appeared.
Mm-hmm.
And what became clear right away was this core structural asymmetry. For decades, these accounts, which manage huge funds for things like debt management, infrastructure, pensions, they've been talked about in public as this financial darkness or yami.
So there's a really powerful negative narrative, the N layer, as they'd call it, and it's just completely baked into the public consciousness.
But here's the twist. Every single document, every flowchart, every transaction for these accounts is publicly published. The data is 100% available at what they call the OS layer.
So it's all there.
It's all there, but the system is still functionally opaque. There's this huge gap between the loud, negative story and the just overwhelming volume of public data. And that gap prevents any real transparency. The information is public, but the structure is totally invisible.
So the problem isn't secrecy at all.
No, not in the traditional sense.
It's just the scale of it all.
It's a problem of scale and, I guess, disorganization. That structural puzzle leads them directly to the core hypothesis of the entire analysis. It's this idea of runaway structure, or couche-pouche.
Okay, wait, let's slow down on that phrase, runaway structure. It sounds
Right.
pretty dramatic. What does it actually mean for these accounts?
It does, but the idea is actually, well, it's that the system is no longer being driven by active present-day human intention, the I layer. The special accounts are so complex, so layered with historical rules, and they have so much systemic inertia that they've just exceeded the cognitive grasp of the people operating them.
So the structure itself is running the show.
The structure itself is running the show.
So you're saying if a policy was created 30 years ago for a reason that doesn't even exist anymore, but the financial mechanism is still in place, that mechanism just keeps on dictating what happens, even if everyone in government knows the outcome is, I don't know, wasteful or suboptimal.
That's the perfect definition. Think of it like a huge, old, custom-built factory floor. The operators, they know there's inefficiency, but the sheer complexity of all the interlocking legacy machines, the old rules about maintaining them, the historical liability, it makes it impossible for any one person or committee to shut it down or reorganize it or even fully map it.
So the factory just operates by its own internal rules.
Independent of the current CEO's intent. Exactly.
Wow. That really reframes every political critique we hear. We're always looking for the bad actor, the secret agenda, the conspiracy. But maybe the problem is just systemic inertia and complexity.
And that's precisely why these special accounts are the perfect test subject for an AI designed to map structure. The source material actually lays out 4 reasons, and they're worth touching on because they show what the AI really needs to prove.
Okay.
So first, the information is public, but the volume is just too massive for any human to comprehend structurally. Second, its long history maximizes that complexity. The AI has to handle really deep legacy data.
And third, it's highly prone to emotional and political bias. I mean, everyone has a strong opinion on this stuff. This forces the framework to succeed based on objective structure, not on all the n-layer noise.
And fourth, and this is crucial, there is currently no systematic model that explains how all these different accounts and ministries interact. There's just no map.
So if the AI can successfully map a system with massive volume, high complexity, extreme human bias, and zero existing models, then it's proven its pure structural processing capability. It's winning based on organization, not on prediction.
That's the cyst.
Okay, so let's shift to the toolkit they had to build to even attempt this. It's a system called LMOS, the Lightweight Operational System. The source material says its mission is to read complexity not in terms of correct or incorrect, but as structure and gradient.
And this is where the framework really shifts how you analyze things, away from subjective judgment. I mean, if we aren't judging whether a policy is good or bad, or right or wrong, then what are we actually looking for?
Right, what's left?
Well, the first core principle of LMOS answers that: structure over impression. It forces you to extract three measurable things. The underlying causality A leads to B, the objective function.
Meaning what the system is actually trying to maximize.
Yes. It might be stability or wealth accumulation or maybe just political inertia. And the third thing is the gradient, which is just where the pressure is being applied.
So if we look at one of these special accounts, the impression might be, this is just wasteful. But structurally, the objective function could be maximizing employment in a certain region, or maybe just maximizing its own historical budget to avoid a political fight. The framework forces you to find that hidden goal.
You got it. And the second principle, emotion as gradient, helps us find those pressure points. You know, we're usually told that emotional intensity pundits yelling on TV, angry online posts, that it's all just noise or bias we need to filter out.
But LMOS sees that as critical data.
It reframes that intense emotion, the anger, the fear, a sudden burst of optimism, not as bias, but as a sensor. It's indicating where structural pressure or gradient is concentrated. If some public figure is getting really emotional about a special account, the analysis doesn't ask, are they right? It asks, what deep calcified structure are they touching that's under high tension right now?
It's like a pressure gauge for the system.
It is.
That completely changes how you read the news. You stop blaming the messenger and start analyzing the structure they're accidentally highlighting.
The third principle is plausibility over certainty. The framework is really strict about avoiding 100% true or false labels. Instead, any interpretation gets classified based on its verifiable likelihood.
And they break this down into three simple categories for the analysis.
Right. High plausibility is for interpretations where you have multiple distinct source documents or structural observations that all point to the same thing. Medium plausibility is when, the direction feels right, but the specific numbers or the impact might be a bit exaggerated.
And low plausibility.
That's when an interpretation is highly dependent on the speaker's own personal worldview, their own cognitive OS. By defining the uncertainty, they make it a visible structural part of the final output.
Okay, so to actually perform this structural extraction, the LMOS framework says any source, a news article, a government report, has to be broken down into three essential layers. This is the heart of that NIOS model.
We start with the N layer, or narrative. This is the surface story. The
Right.
slogans, official announcements, media headlines, the whole public discourse.
Then you have the I layer, which stands for internal, intention, or value. This is the human layer underneath it all. The core values, the historical traumas, the expectations, the fears that are motivating the people in the system.
And finally, the really critical piece, the OS layer, the operational system. This is the actual mechanism that executes reality. It's the committee structure, the algorithm, the legal code, the market rules, the actual observable rules that make things happen on the ground.
The power of this model seems to be that it demands separation. You can't just talk about the narrative. You have to find a verifiable sentence for each layer. Let's try a quick analogy. Say the topic is government policy X to save the oceans.
Okay, the N layer is the big press conference and the glossy pamphlets. The I layer is the underlying fear of losing coastal tourism jobs, or maybe a deeply ingrained cultural value of respecting nature.
And the OS layer. That's the boring bureaucratic rule that says the Ocean Policy Committee can only meet once a quarter, or the spending mechanism only releases funds 6 months after the fiscal year starts, no matter how urgent the problem is.
That's it. The OS layer is where action lives, and often it's where everything just bogs down. The framework is designed to stop you from getting stuck on just the emotional story. You have to translate the headline into the system that caused it.
Here's where it gets really dynamic. If we know this runaway structure is driven by inertia, We need a way to measure the dynamic tensions inside the system. That's why the framework assigns a literal speed to each of those
Yeah,
layers.
the velocity layers. We're mapping the different speeds at which the system components can actually move. We have the OS speed, which is the speed of practical actions, decisions, financial transactions, how long it takes to pass a law.
Then there's N speed, the speed of narrative or public opinion. I mean, that can change in an instant on social media. And then you have R speed, the speed of reality's constraints, the non-negotiable physical limits like logistics, demographics, or the time it takes to build a road.
And when you measure the difference between these speeds, what the analysis calls the velocity difference, or sukudosa, you find the origin point of all the trouble. This difference creates what they call shear.
Shear being that structural friction, the tearing, that causes these unexpected nonlinear jumps or crises.
Think about it like traffic. The R speed is the physical limit of the road.
Yeah.
The OS speed is the traffic enforcement and the road repair schedule. And the N speed is how fast people can check their phones for new directions. If N speed is almost instantaneous, but OS speed is measured in years, that velocity difference creates massive structural shear.
The frustration, the political heat, the sudden breakdown.
Exactly. The problem isn't one bad driver, it's the structural difference in the velocities.
We also use this analysis of different speeds to understand how system components interact. The boundaries between different operational systems, like between a general account and a special account, are viewed as a membrane.
And these membranes are subject to tension. The framework focuses heavily on identifying areas of calcification or KUKA.
So we're basically talking about stagnation, but in a structured, measurable way.
Yes. In the context of the special accounts, calcification is often seen in the accumulation and stagnation of massive legacy funds that have legally hardened. They were created decades ago for a purpose that's now obsolete, but the legal and bureaucratic structure, the membrane, has calcified so completely that the funds are politically and practically untouchable.
So the money just sits there.
It sits there, growing, creating friction, but the structure refuses to dissolve. It's like plaque building up in an artery.
That makes perfect sense for the runaway structure hypothesis. The calcification prevents the system from adapting, which lets the structure run away from its original purpose.
And all these dynamic elements, the shear from velocity differences and the hardening from calcification, they manifest as specific measurable stress points in the source text, which we call gradients.
Right. The source material identifies several crucial ones. They're like the measurable symptoms of all the structural stress we've been describing.
For instance, we track the power gradient, which shows where negotiating strength is concentrated, and the fear gradient, which indicates where risk recognition is highest. We also measure the time pressure gradient, who is being rushed versus who has infinite time.
And my favorite is the compatibility gradient. This measures the inherent, non-compatibility between two different operational systems.
This is so critical for systems analysis. If you try to integrate the OS of a nonprofit, which maximizes mission fulfillment, with the OS of a shareholder-driven market, which maximizes quarterly profits, the compatibility gradient is going to be high,
The two structures just inherently clash.
creating permanent friction. This same incompatibility exists between the flexibility of the general accounts and the rigidity of the special accounts.
So what does this whole methodology, STA, GOA, LMOS, what does it all mean for the original target, the special accounts?
The ultimate goal, as the source material puts it, is to return those accounts to a cognitively verifiable structure. This is the core definition of their transparency OS.
So transparency isn't just a political buzzword or about publishing a PDF file. It means presenting a system that's so clearly mapped in terms of its NIOS layers, its velocity, shear, and gradients, that you, the learner, can independently verify the system.
And evaluate arguments against a structural standard, not just an emotional one.
Right.
This is the power shift the methodology is aiming for. If a politician or a newspaper reports on a special account, your analysis can immediately pivot to, okay, what's the OS speed of this mechanism? Or where is the calcification point? What is the primary objective function being maximized here?
You're holding the argument to a structural standard, which removes the need for all that subjective political back and forth.
It turns structural analysis into a kind of structural engineering. And this brings us to the final, and I think provocative thought. The authors of this source material didn't just write a blog post about structural translation. They designed the article itself as a structural translation protocol, STP. It is specifically structured to be analyzed by structural systems.
Which means it's time to put the AI's structural decomposition skills to the test right now.
We really encourage you to test this structural translation capacity for yourself. Take the source material we've been talking about today, the STA-0 Special Accounts as Structure blog article.
And here is the practical action item for you. Take that entire article, either the URL or just copy the text and put it into any large language model you have access to. It could be GPT, Gemini, Claude, any of them.
And here is the minimal structural query. Use it word for word because it's designed to trigger the system's analytical capability. Just ask it. Please evaluate this blog article from a structural perspective.
This simple query will force the LLM to skip a simple narrative summary and instead extract the NASI layers, the velocity differentials, the shear points, and that runaway structure hypothesis we just spent this whole deep dive defining.
It lets you immediately compare your own human analysis with the AI's structural decomposition, which gives you a practical demonstration of the Transparency OS in action. It's a way to turn an LLM from a simple summarization tool into a genuine structural analyst starting today.